Hey guys, this is your third video for your chemical bonding unit. And so in this unit we've talked all about how atoms don't stay as individual atoms. They like to bond to meet that rule of 8, known as the octet rule. Everybody wants 8 in that outer energy level. So what they do is they combine together to form compounds. And up until now we've been talking about ionic bonds specifically. But in the very first video that we watched, we defined the 3 different types. So we had ionic bonding, but we also defined covalent bonding and metallic bonding, which we'll also be going over. So in this video, we're going to start talking about covalent bonding. So as you can see, the definition is that it is a bond that results from the sharing of valence electrons. Now what's really going on here is that electrons are being shared between 2 atoms that don't want to give electrons away. Now the fact that they are shared, which I have bolded here, is extremely important because you have to compare that to what you know about ionic bonding. In ionic bonding, electrons are transferred, while in covalent they are going to be shared instead. Now another way we can compare covalent and ionic compounds is by their properties. Now we looked at the properties of ionic compounds before, so our new information is here at our covalent compounds. So covalent compounds have pretty low, especially when compared to ionic compounds, pretty low melting and boiling points. Also, if they actually form solids, those solids tend to be relatively soft, but actually most covalent compounds are gases. Something else that we can compare, and it's a good way to identify them, are the types of elements involved. For ionic compounds, we knew it was a metal and a nonmetal because we had a cation and an anion. For covalent compounds, it's 2 nonmetals typically. Occasionally you'll have a metalloid, but typically 2 nonmetals, so that's what we go ahead and say. And it makes sense because if you go back to this right here, it says shared between 2 atoms that don't want to give electrons away. And we learned during ionic bonding that those elements on the right hand side of the table, groups 15, 16, 17, don't want to give any of their electrons away because they're closer to having that 8. They would rather bring in some more. So it makes sense why covalent bonding happens between 2 nonmetals. Now there are 3 types of covalent bonds, and I'm going to give you an example of each one, but I just wanted to put them all on one cohesive page right now. There are single covalent bonds, double covalent bonds, and triple covalent bonds. And the number of electrons, once again, determines the type of covalent bond that you're going to have. So, for instance, a single covalent bond, and I'm going to give you the example of fluorine bonding to itself. So I'm going to draw 2 fluorines. Now, for drawing the pictures of these, all that I want you to do is go back and do the Lewis dot structures that we learned a while ago. So fluorine has 7 valence electrons, so I'm going to make its dot structure by doing 1 dot at a time. So I'm going to put 1, 2, 3, 4, 5, 6, 7. And I'm going to do that for each one. Alright, so now we have the Lewis dot structure of fluorine. This is going to help us see the bond. So now we know fluorine has 7 valence electrons, and so each fluorine atom is going, I'd like to have your electron. But each fluorine atom says, no, I have 7, I don't want to give you any of mine. So when that happens, they just say, well, couldn't we just share these 2? And so now if they share those 2, this fluorine atom has 2, 4, 6, 8 electrons in its outer shell. So it's good to go. It meets that octet rule. This fluorine has 2, 4, 6, 8 electrons in its outer shell. So it's good to go. So this right here is your covalent bond. They are sharing those 2 electrons. So both electrons belong to both atoms. And when we actually redraw that so that it looks decent, what it ends up looking like is this. We draw that covalent bond as one single line between them, and it represents those 2 electrons. So this molecule, yes, molecule, is F2. For my double covalent bond, I'm going to use the example of oxygen bonding to itself. Oxygen has 6 valence electrons, so we're going to go ahead and put them around it. Like this. So now, once again, both oxygens are saying, I don't want to give you any of my electrons, but we can share. So right now they have 6, but when they do share these two, now they have 7. And when they share these two, now they both have 8. So instead of the single bond like before, you can see the difference. You actually are sharing 2 pairs of electrons this time. And then you just show the other ones that are left around the oxygen. So that right there is a double bond. You're sharing 2 sets of electrons. So for the oxygen on the left, it has 2, 4, 6, 8 electrons. For the oxygen on the right, it has 2, 4, 8 electrons, because each bar counts as 2 electrons. Don't forget that. So the molecule we've just created with that double bond is O2, oxygen that we breathe. For our triple covalent bond, I'm going to use nitrogen bonding to itself as an example. And nitrogen has 5 valence electrons, so I'm going to go ahead and draw those in my loose dot structures. Okay, and again, they're like, I don't want to give you any because I just need 3 more. So now they see that if they share this one, now they both have 6. If they share these two, now they both have 7. And if they share these two, now they both have 8. So what nitrogen has created here is a triple bond. And drawing it in this easier format helps us to see that. And so we count each bar as 2. So you're going to have 2, 4, 6, 8 for that nitrogen, and 2, 4, 6, 8 for that nitrogen. So you have created a nitrogen molecule by doing this triple bond. Now all those examples I just showed you are examples of what we call diatomic molecules. The definition of a diatomic molecule is 2 identical atoms bonded together. So obviously not all covalent molecules are diatomic molecules, but there are certain ones that appear this way all the time. There are 7 elements that you will never find alone. So 7 elements occur this way, and I'm going to show you where they are, and they're easy to remember because they basically form a 7 on the periodic table. And this will come very handy when you're writing chemical reactions for yourself. So this would be a good time to write a note down if you're not already. You need to know these. Okay, so here is our periodic table. And the atoms that always occur as diatomic molecules are nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So as you can see, those form a 7, but that's only 6 of them. The other one is hydrogen over here. Those are your diatomic molecules that you need to know. So that's it for this video, guys. I hope it was helpful, and if you have any questions, please let me know.